Xavier, go to me number 6.
Number 6.
Mm-hmm.
Which of the following functions shows that the statement, if a function is continuous at x equals 0, then it is differentiable at x equals 0 is false?
All right. So it looks like there might be how many answers on this one?
3.
Oh, 3 of them. Oh, there's actually, answer choice A is gone, right? Actually, it's on there. Okay, A is there, B is there, C. What about E? It should be x cubed. I think the box kind of ate it up. Oopsie. Oops. Okay, let's graph some pieces that we already kind of know how to graph. So I'm going to go back to our rational functions. If y'all remember back in, even in algebra 2, when you had rational function of 1 over x, the graph basically had everything in quadrant 1 and everything in quadrant 3. Oh, there's a little shadow. And we know that meant it's going to be basically obviously not even continuous, right? So looking at this, the way I can rewrite this would be x to the power of -1. So let's kind of compare with that one. Anything that's got a power of -1, go ahead and circle them. These are all going to have like an alternating graph on the other side. So we know automatically it's going to look very similar to this. So could I cross off A and B right off the bat? Yeah? Because it says it is continuous, but we have to see that it is differentiable at x equals 0 is false. Okay, let's do the one that we already know. Look at E. Isn't that a cube function? The cube function kind of behaves a little bit similar to the tangent function. And we know this is smooth. I see no cusp. And what was the other one? Jump. So therefore, this one is continuous and differentiable. So this one is continuous and differentiable. And then the next piece. For those of you guys that are thinking, how do we know how something is the way it is? I want you to look at the power with the odd and the even number. When you have an odd number, it actually comes together in this format. When you have an even number, it's going to create a parabola. So we know this one is continuous and differentiable. What does this have that is not differentiable? There is a cusp. So therefore, C is going to make it false. Now let's go to, was it number 11? 11. All right. So on number 11, Cody, let's go ahead and read that out loud, please.
F prime of x equals cosine x, and g prime of x equals 1 for all x, and if f of 0 equals g of 0 equals 0, and limits x approaching 0, f of x over g of x is.
So let's go ahead and plug in the 0 first. When I plug it in, we get f of 0, g of 0. And then it tells us that f of 0 is 0 and g of 0 is also 0. So when I have 0 over 0, what was that rule that I taught you guys today? We have L'Hopital's rule. So I'm going to write L'Hopital's rule over here since I have room. And let's go ahead and see what we have. I need to find the derivative of the f of x. The derivative is f prime of x. And then I need the derivative of g of x, which is g prime of x. Don't I know what those components are by the given? So when I plug it in, I get cosine of 0 and 1. I should have written limit as well. Oops. And then just a recall, cosine at 0. Our order pair is 1, 0. Cosine, is it opposite movement or adjacent movement? Adjacent. So we know all of cosine is equal to 1 over the 1. It's going to approach 1.